Now we're going to talk about a topic that can be more challenging than what we've discussed before, but there's a little tip that if you follow this hint, it makes these problems much easier. So we're going to talk about combinations of functions. And right away I'll tell you the thing that makes performing combinations of functions challenging is if you don't follow the hint that I am going to give you in a moment, then you can mix up the order of the transformations. Let me show you what I mean by that. So I have this g of x function, which is 2 times x squared plus 1. Now here, we're transforming this toolkit function x squared. So I could rewrite this as 2 times f of x plus 1. And I see that there's a vertical stretch by a factor of 2, and there's a vertical shift by 1, upwards. The challenging thing here is if you mix up these transformations, well, you get two different functions. Let me show you that by an example. Now, I'm not going to go and graph the entirety of x squared, but we all know that 2 comma 4 is on the graph of x squared. So if we wanted to go perform these transformations, we would have to transform the point 2 comma 4. Let's apply the shift, then the scale. So if we do the shift first, then we would get to 2 comma 5. We would add 1 to the y value. And then if we applied the scale next, we would multiply the y value by 2. We would get 2 comma 10. So 2 comma 4 would get transformed to 2 comma 10. And this is doing the shift first. What if you did the stretch first? Well, then 2 comma 4 would first get transformed to the point 2 comma 8, which would then get transformed to the point doing the shift by 1, 2 comma 9. So this is with the stretch first. One of these is correct and one of these is not. And the challenging part about combinations of functions is how do I determine if I should do the shift first or the stretch first? The resolution to this is if you follow the tip that I give you, you will always do the shifts last. Now, before I tell you how to do this, I want to tell you when you need to worry about this. Because throughout the videos, there's been a couple times when I've said, the order doesn't matter. You don't need to worry about the order of the transformation. So when precisely do we need to worry about the order? There's two things that you need to consider, or perhaps more accurately, look out for. You'll need to worry about this when there is a vertical stretch, compression, reflection, and a vertical shift. Let's put and instead of plus here. And you need to worry when there's both. So if there's just a compression and a reflection vertically, you don't need to worry. But as soon as there's a vertical shift and one of these stretch, compressions, reflections, then you need to worry. And the other scenario in which you need to worry is if there's a horizontal stretch, compression, reflection, and a horizontal shift. One thing at this point that I think is important to notice is you can mix up vertical and horizontal transformations as you wish, and you'll get the same graph. You don't have to worry about that scenario. So for example, if you have a vertical reflection and a horizontal shift, and those are the only transformations that are in your problem, you don't have to worry. And more specifically, what I mean by worry is if you change the order of these transformations, everything will be fine. However, as soon as you add in a horizontal reflection, you have to start thinking about the order. Let's go to an example and determine which of these examples we have to think about the order carefully. Okay, I have 4 examples here. Let's go through them one by one, and let's try to determine if we need to worry about the order of the transformations. Let's start with this first one. What type of transformations do we have? We have this -1/2 on the outside of f. That's going to contribute to a vertical compression and a vertical reflection. We have this -1 on the inside, which will be a horizontal shift, and we have this +2 on the outside of f, which is a vertical shift. Since we have both a vertical shift and a vertical compression, and a reflection in fact, we have to worry about the order of the transformations in this problem. Now I know I haven't told you how to exactly determine the order of the transformations here, but half of these problems is knowing when the order matters. So that's why we spend so much time talking about this. Let's go to part B. So actually, I think I'll put worry here. What transformations do we have in part B? Well, we have this vertical stretch. We have this horizontal reflection. It's horizontal because it's on the inside of F. And we have this horizontal shift. Since we have both a horizontal reflection and shift, we have to worry about the order. What about in part C? In part C, we have a vertical compression and a horizontal shift. We do not need to worry about the order in this problem because, going back a little bit, we only have to worry about the order when there's a horizontal stretch, compression, reflection, and horizontal shift. In this case, we only have a horizontal shift, and we only have, in the vertical, category here, we only have a stretch. Now, if there were a vertical shift, we would have to worry about the order, but there's not. And if there were something like a horizontal compression, stretch, or reflection, we would have to worry about the order, but there's not. So in this part C, we don't have to worry. About the order. And then finally in this part D, first we have this horizontal shrink. Remember, or I believe we call them compressions, not shrinks. In other texts, they're called shrinks. We have this horizontal compression. Remember, it's compression because the horizontal transformations are a little strange. If the number multiplying x is bigger than 1, you get a compression. If it's between 0 and 1, you get a stretch. And then we have a vertical shift. And again, if we look back, we have a horizontal compression and a vertical shift. So we do not have to worry. Okay, so don't have to worry about the order for these last two. Now that we've looked at a specific example so we can understand when the order matters, let's talk about this tip that I've been referring to that will help you in these instances. And the tip is this: make sure that 2 things are true. The first is the vertical stretch does not multiply the shift as well. Let me show you what I mean by that. So if you have something like 2 parentheses f of x plus 1, and it would be accurate to say the vertical stretch slash, and I have a little space here, compression slash reflection. So make sure that anything corresponding to the stretch, reflection, or compression does not also multiply the shift. So for example, what I have here, 2 times f of x plus 1, the stretch is here. It multiplies both f and the shift. We do not want to see this. What do you do if your problem does look like this? Because maybe you're given a problem that looks like this. You can simply distribute this 2, and you get 2f of x plus 2, and now you have a form where the stretch does not also multiply the shift. For example, if you had negative f of x minus 1, well, you have a reflection multiplying both f and the shift. That is not the form that you want. We're going to go ahead and distribute that negative, so we get negative f of x plus 1. And now the reflection only multiplies f. So anything corresponding to a reflection, compression, or a stretch should not also multiply the shift. And practically speaking, that means that you don't have a number and then parentheses f plus or minus something. Now the second part of this tip has to do with the horizontal transformations. And for the horizontal transformations, you have to actually make sure that the opposite is true. So the horizontal stretch slash compression slash reflection does multiply the shift. Let's take a look at a practical example of that. So what if you had something like f of 2x minus 1? So this horizontal compression does not multiply the horizontal shift. Algebraically, it's a little bit more challenging to remedy this. So in order to write this in a form where the horizontal compression does multiply the shift, we need to factor the horizontal compression or reflection or stretch, whatever you have in your problem, out of both the first and second term. So 2x minus, and then you have to ask yourself, what do I need to put here so that if I were to distribute, I get my original problem? Well, if you were to distribute this, you get f of 2x minus 2 times question mark. And so this 2 times question mark would have to be the same as 1. Well, 2 times 1/2 is the same as 1. So essentially you're asking yourself 2 times what is equal to 1? And the answer is 1/2. So we can rewrite this in the form f of 2x parentheses, f of 2 parentheses x minus 1/2 parentheses. And now my horizontal compression is multiplying both x and the shift. Another example of this, what if you had f of negative 3x plus 7? We want our horizontal compression and reflection to multiply the shift as well. So we'll go ahead and factor out this negative 3. Negative 3x plus negative 3 times what would be 7? That's what we have to ask ourselves. Okay, negative 3 times what is 7? So this would be negative 7/3. So I can, instead of writing plus, I'll go ahead and write minus and 7/3. Okay, so the tip here is to make sure first that the vertical stretch, compression, reflection does not multiply the shift as well. If it does, then you simply have to distribute this vertical stretch, compression, or reflection. And then the second tip is make sure the horizontal stretch, compression, reflection does multiply the shift. And if it doesn't, like in these examples that I have given here, then you need to factor out the horizontal stretch, compression, or reflection from both terms. Now, that's a good amount of information, but the result of following this tip is very nice. So if you follow this tip, as I said before, the only thing that you need to do in order to do these transformations in the right order is make sure that the shift happens last. So the order will always be correct. If you do the shift last. So for example, if you were doing a problem and you followed this tip, then you could do something like all the vertical, not scales, all the vertical stretches, compressions. Then you could do vertical reflections, and then vertical shift. And as long as this shift is last when you do all the vertical transformations, then your transformation order will be correct. Same with horizontal. So you can do horizontal stretch / compression, horizontal reflection, and as long as you do this horizontal shift last, your order will be correct.